Hello, and welcome to a journey where scientists challenge the Big Bang Theory with a new quantum explanation. Did you know that our origin may not have been an explosion in empty space, but a silent birth inside a black hole? We once believed that time emerged from a singularity exposed to nothingness, but recent calculations suggest that our universe may be the inside of a star that collapsed in another reality, shielding us behind an event horizon. What exists beyond that wall? Let's explore black hole cosmology and how it removes the need for a chaotic beginning. Let's walk through the studies that connect extreme gravity to the creation of new realms of space. Let's imagine the scale of this cosmic womb and feel the mystery of dwelling within the depths of a giant. But before we continue, I need your help. If this kind of exploration resonates with you, consider supporting the work here on Cosmos for Rest. You can subscribe to stay connected to future journeys and share this experience with someone who might find comfort in it. Your quiet support allows this space for calm scientific reflection to continue. Now, relax, close your eyes, and let science guide you. To begin this journey, we need to return to a moment that, paradoxically, may never have existed in the way we were told. Let's walk together to the very edge of human understanding, to that point on the timeline where clocks stop and the laws of physics as we know them dissolve into mystery. For nearly a century, we accepted a fascinating, yet incomplete story about our own origin. We accepted the idea that about 14 billion years ago, everything that exists, every star, every galaxy, every atom in your body, and even empty space itself, was compressed into a single, unimaginably hot and dense point. We call this the Big Bang. The image is powerful. A great explosion of light and energy breaking the silence of absolute nothingness, creating the stage where life would eventually dance. It is a beautiful narrative, almost mythic, giving us a sense of beginning, middle, and end. And yet, when the brightest physicists in the world attempt to examine that zero instant under the strict lens of mathematics, they encounter something unsettling. They do not find a clear beginning, but an error, a logical abyss. According to Einstein's general relativity, if we rewind the cosmic film all the way back, all the mass of the universe would be squeezed into a space of zero volume and infinite density. In physics, we call this a singularity, and although the word sounds technical and elegant, to a scientist it is a warning cry. A singularity is not a physical thing. It is the moment the equation breaks, where the cosmic calculator divides by zero and stops working. To say the universe came from a singularity is essentially the scientific way of saying, beyond this point we do not know what happens. It is an impenetrable wall of fog for classical physics, and it is precisely at this point of intellectual discomfort that our new story begins. It is here, at this exact point of intellectual tension, that a new possibility begins to emerge. Because nature, in its quiet wisdom, rarely deals in true infinities or absolute zeros. Nature prefers transitions, and that is why a group of theoretical physicists began to look toward another cosmic phenomenon that also contains one of these mysterious singularities at its core: black holes. Think for a moment about what a black hole truly is. It is the final act in the life of a massive star, a giant that has exhausted its nuclear fuel and can no longer support its own weight. Gravity wins its long battle against internal pressure, and the star collapses inward, imploding with such colossal force that it punctures the very fabric of space-time. To an outside observer, the star disappears, leaving behind only a dark silhouette and a gravitational field from which not even light can escape. But here is the question, the one that will guide us gently forward. Where did that star go? Matter cannot simply vanish. Quantum physics teaches us that information and energy are never destroyed. They only change form. So if that immense mass was crushed and swallowed by a point of supposedly infinite gravity, it must still exist in some state. It must be somewhere. And this is where the new quantum explanation challenges the traditional Big Bang with unsettling elegance. What if the singularity at the center of a black hole is not an ending, but a passage? What if, instead of being crushed into oblivion, the matter that falls inward is funneled to the other side, expanding once more? This is the bold proposal of black hole cosmology. It suggests that what we call the Big Bang was not an explosion emerging from nothingness, but the precise moment when a star collapsed within a parent universe and formed a black hole. On the other side of that collapse, shielded by the event horizon, that dark boundary from which nothing returns, Matter burst outward into a new dimension, creating our universe. Pause for a moment and feel the vertigo of that possibility. It would mean that our entire cosmos, with all its immeasurable vastness, is the interior of a black hole existing in a far greater reality. Our beginning would not be a spontaneous accident, but the final breath of a star somewhere else. This perspective resolves one of the greatest puzzles of modern cosmology, the problem of the first cause. In the older model, we were forced to accept that the universe began just because, without a physical trigger. But in this quantum view, the trigger is natural and familiar: stellar collapse. Extreme gravity bends space so profoundly that it forms a bubble, a new pocket of reality that disconnects from its origin and begins to grow on its own. Imagine space-time as an elastic fabric. If you press a heavy object onto it, the surface dips. Press harder and it sinks deeper. Push far enough and the fabric gives way, forming a new bulge beneath, separate yet born from the first surface. We would be living inside that bulge. This idea reshapes our sense of isolation. We are not a lonely accident. We are the offspring of an astrophysical process. There is something almost biological about it. Universes generating universes, forming a cosmic family tree without end. The bang we speak of would simply be the impact of matter from the parent universe crossing through and finding room to expand here. And what we interpret today as the accelerating expansion of our cosmos could be the lingering inertia of that primordial fall, the gravitational memory of that passage. Under this lens, the darkness between the stars acquires a new meaning. We are not gazing into passive emptiness. We are observing the inner structure of a colossal object. The laws of physics that govern your daily life, the gravity holding your feet to the ground, the light warming your skin, may be the internal rules of this black hole environment. And this leads us to a profound question that we will carry with us. If our universe was born from a black hole, could every black hole we observe within our own galaxy also be nurturing a universe inside it? Are we, unknowingly, carrying trillions of infant universes within our own cosmic domain? Notice how this shift removes violence from the concept of creation. There was no chaotic detonation from nothing. There was a transformation, gravitational energy converting into spatial expansion. The blinding white of the Big Bang would be the mirror image of the absolute black of a black hole. The same doorway, viewed from opposite sides. To those in the parent universe, the star went dark. To us, on the inside, the light turned on and became everything. It is a poetic duality, one that quantum mechanics embraces. Different observers witnessing opposite realities that are, at their core, the same truth. Let this idea soften your sense of finality. If the universe is not a disposable accident but part of a greater reproductive mechanism, then continuity is eternal. Time did not begin here, it flowed into here. The matter that forms your hands, the water you drink, the air you breathe, perhaps all of it once belonged to a brilliant star in another universe, a star that lived, shone, and died so that we could awaken. We are, quite literally, stardust from another dimension, reorganized and brought to life through a tunnel of gravity. And if this is so, then living inside a black hole is not an abstract theory. It defines the very texture of existence. It raises quiet questions. Are there boundaries we can never cross? Is there a physical limit to how far we could ever travel? Science begins to suggest that the event horizon is not merely a prison, but a shield. It protects us. If exposed to the parent universe, perhaps its physical laws would be incompatible with life here. The black hole functions as a greenhouse, a controlled environment where gravity, temperature, and nuclear forces found the delicate balance required for galaxies to form and consciousness to awaken. We are safe inside. What once seemed like a terrifying abyss reveals itself as a sanctuary, a capsule of time and space drifting through eternity. With this sense of protection, of being held within the womb of a cosmic giant, we release the image of a random explosion and embrace the possibility of a structured birth. From here forward, we will explore how this reality manifests in the subtle laws that govern your daily life and in the strange familiarity you feel when gazing into the star-filled void. The universe is not foreign to you. It is inheritance. Now that we have crossed the theoretical threshold and allowed ourselves to inhabit this new possibility, we must bring our attention back to something simple and immediate. Your hands, the clock on the wall, the quiet weight of the floor beneath you. If we truly live inside a black hole, this is not a distant curiosity about remote galaxies. It is a condition that governs every second of your existence. The physics that regulates your sleep, the rhythm of your blood, the falling of a leaf in autumn, all of it, in this view, is a direct consequence of dwelling within a curved and enclosed space. So let us set aside the question of cosmic origins for a moment, and focus instead on the lived experience of being here. What does it mean to inhabit the interior of an expanded singularity? The first and most profound consequence is something you feel constantly, yet rarely question: the dictatorship of time. Have you noticed how time moves only in one direction? You can step left or right. You can jump upward or bend downward, but you can never take a step toward yesterday. Why is time a one-way corridor? In classical physics, this was always a mystery, but within the geometry of a black hole, it becomes inevitable. When something crosses the event horizon and falls inward, space and time exchange roles. What once was a spatial direction becomes a temporal one. The path downward toward the center ceases to be a distance. It becomes the future itself. Pause with that idea. If we are inside a black hole, then the reason you cannot stop time is the same reason a stone cannot stop falling. We are all in constant free fall through the fourth dimension. Tomorrow is not a destination we choose to visit. It is the direction toward which the gravity of the entire universe is pulling us. Aging, then, is not merely biological wear. It is motion through cosmic geometry. Each heartbeat is another meter traveled in this gentle descent toward the future. Seen this way, time loses its melancholy. We are not losing it. We are moving through it, carried by the very architecture of our cosmic home. Now consider space itself. Astronomers observe that galaxies are drifting away from one another. The universe is expanding. In the older model, this was described as leftover momentum from an initial explosion. But if we live inside a black hole, expansion acquires a far more organic meaning. Picture the black hole from the outside in its parent universe. If it continues consuming matter, it grows. Its mass increases. Its event horizon, its boundary, expands. And if the boundary expands, what must happen to the interior? It must grow as well. The expansion we measure within our universe may be a direct reflection of what the black hole is absorbing beyond our reach. Every star or cloud of gas devoured in the parent universe could be converted into fresh space and energy inside our own. There would be an invisible connection between us and a cosmos we will never see. When our universe stretches, perhaps it is because the shell that contains us is being fed. We are expanding because our cosmic womb is expanding. This transforms isolation into participation. We are not sealed in a static container. We are part of a dynamic system responding in real time to gravitational feasts occurring in a higher dimension. The universe is not inert. It grows. Another subtle trace of this condition lies in temperature. Deep space is not absolute zero. It carries a faint uniform radiation, a residual warmth known as the cosmic microwave background. Conventionally, this is described as the echo of the Big Bang. But black hole physics introduces another phenomenon: Hawking radiation, a faint thermal energy emitted at the event horizon. If we are inside such a structure, then the boundary of our universe must possess a specific temperature. And intriguingly, the temperature we measure in the cosmos aligns remarkably well with what thermodynamics predicts for a black hole of this unimaginable scale. The cold of deep space may be the warmth of our surrounding wall, a subtle thermal signature of the boundary that protects us. And this leads us toward one of the most astonishing implications of modern physics: the holographic principle. According to this idea, all the information about what falls into a black hole is encoded on its surface, on the event horizon. If that is true, then everything inside, all three-dimensional reality, may be a projection of two-dimensional information stored at the edge. Imagine a cinema screen. The film exists on a flat surface, yet you perceive depth, motion, emotion. Physics suggests that we may be something similar, a three-dimensional rendering of information written on the cosmic boundary. The real data would reside on that distant surface. Our bodies, planets, and stars would be the immersive projection of that encoded structure. This is not fantasy. It emerges from serious attempts to reconcile gravity and quantum mechanics. If so, solidity becomes interpretation. The texture of fabric against your skin, the weight of your body, the structure of mountains, all of it would be high-resolution renderings of information stored at the horizon of the universe. Matter would not be fundamental. information would be. This perspective explains something curious about the quantum world. When scientists zoom in deeply enough, beyond atoms, beyond protons and electrons, they reach a limit, the Planck scale. Below this scale, space itself ceases to behave meaningfully. It is as though reality has pixels. If you zoom in far enough on a digital photograph, you see squares. If you zoom deeply enough into existence, you find discrete units of length, the smallest possible resolution. Perhaps we are living inside a cosmic hologram with a finite pixel size. This changes how we experience ordinary life. We are not solid beings wandering in emptiness. We are complex patterns of information vibrating within a projection sustained by gravitational geometry. Your consciousness, your memories, your identity, they would not vanish. They would be encoded in the boundary of eternity. Nothing is truly lost because information at the event horizon cannot be destroyed. When we understand time as descent, expansion as nourishment, and matter as holographic projection, the strangeness of quantum mechanics begins to feel less threatening. It becomes the internal logic of our environment. We are living within a mathematical miracle. And yet, despite this complexity, human life remains simple. Breathing, resting, dreaming. The unimaginable machinery of black hole physics operates silently in the background, allowing you to lie here now in peace. If we could adjust our vision further, not to see what is small, but to see what is fundamental, we would descend below cells, below molecules, below electrons orbiting atomic nuclei. We would enter the basement of existence, where the very notion of place begins to dissolve. There, in the hidden scaffolding of matter, we find the engineering that prevents collapse and confirms that there was no beginning from nothing. We are about to discover the texture of the cosmic floor beneath your feet. For centuries, both science and human intuition treated space as something smooth and continuous. Imagine a sheet of perfectly polished glass, stretching infinitely in all directions. Isaac Newton envisioned space this way, a passive, absolute container in which stars and planets merely moved about. Even Einstein, when he curved space with general relativity, still described it as a continuous fabric, like a seamless rubber sheet. No matter how closely you zoomed in, it would remain smooth. But the new physics, the same physics that questions the singular beginning, brings a quiet revelation. The glass is not smooth. The sheet is not seamless. Space is woven. This is the essence of loop quantum gravity, a framework that supports the idea of an eternal universe. It proposes that space is not the stage where things happen. Space itself is made of things. Imagine holding a finely woven cotton shirt. From afar, it appears like a smooth surface. But bring it close to your eyes and examine it under magnification. There is no continuous surface, only threads. Threads intertwined, forming loops and knots. And between those threads, tiny gaps. The space around you right now, the air in your room, the distance between Earth and the Moon, the void between galaxies, is not continuous. It is granular. It is made of unimaginably tiny loops of gravity interwoven into a three-dimensional chainmail. These loops are called spin networks. They are not inside space. They are space. There is nothing between them. Volume, height, depth. These properties emerge only when enormous numbers of these loops interconnect. Reality, then, has a minimum resolution. There is a smallest possible unit of length, the Planck scale. Below it, geometry dissolves. There is no smaller than that. It is the basement floor of existence. Why does this matter? Because this granular structure is the safety mechanism that prevents catastrophe. Remember the singularity, the terrifying prediction of infinite density. That infinite collapse is only possible if space is smooth and infinitely divisible. If you can compress matter into smaller and smaller points without limit, infinity becomes inevitable. But if space is built from discrete building blocks, there is a boundary. You cannot compress reality beyond the size of its fundamental units. Imagine filling a box with oranges. You can push them closer together, rearrange them, apply pressure, but eventually, the oranges touch. There is no more empty space. Push further, and they push back. In the universe, this resistance is called quantum repulsion. When the previous cosmic cycle contracted, or when the star in the parent universe collapsed to form the black hole we inhabit, matter was not crushed into nothing. It was compressed until the atoms of space themselves touched. At that precise limit, contraction halted, and like a spring compressed to its maximum tension, the only remaining motion was outward. This is the hidden mechanism of the Great Bounce. The granular structure of space acts like a cosmic shock absorber. It guarantees that reality cannot be erased. It can compress, build tension, and then rebound, but never vanish. Feel the stability in that idea. The ground beneath you is not an abyss. It is a woven lattice, firm, interconnected, resilient. There is a limit to chaos. There is engineering embedded within the structure of existence itself that prevents total collapse. The universe is designed to endure. And how does this woven network behave while you rest? It is not static. These loops vibrate. Space-time is a restless foam at the smallest scales. Though you cannot see or feel it, trillions upon trillions of microscopic connections form and dissolve each second around you, knitting reality in real time. Imagine a quiet grandmother somewhere in the cosmos, endlessly knitting. Existence is being woven right now. The continuity of your room, the persistence of objects, the flow of time, all of it emerges from this invisible choreography of quantum loops. Reality is maintained through constant microscopic activity. This perspective also transforms our understanding of the vacuum. We once imagined the vacuum as the absence of everything. But in loop quantum gravity, the vacuum is simply the lowest energy state of the network. It is not nothing. It is the lattice at rest. Even in the emptiest regions between galaxies, the geometric fabric remains, silent, waiting to curve when mass passes through it. There is no absolute nothingness. You are never surrounded by void. You are immersed in a subtle geometric medium at all times. Even the speed of light takes on new meaning here. Why does light have a maximum speed? Why can nothing travel instantaneously? Because space is a network. To move from point A to point B, information must hop from node to node, loop to loop, like traveling through a city of intersections. There is a minimum time required to traverse the streets. The speed of light is the maximum processing speed of this cosmic network. The universe has a refresh rate. Its laws are not arbitrary restrictions. They are properties of the material from which reality is constructed. We are limited by the speed of light because we are made of woven space. As you internalize this immense complexity, notice how simple your breathing feels. While your mind drifts toward sleep, this unimaginable quantum machinery continues operating with flawless precision, sustaining every particle of your body, ensuring gravity keeps you gently anchored to your bed, allowing warmth to circulate and time to flow toward morning. It is a silent orchestra performing the symphony of existence so that you can simply rest. You do not need to understand the mathematics of spin networks to benefit from their stability. Knowing that the universe has structure, that it is not a chaotic fog, provides a foundation for deep relaxation. And some theorists go even further, suggesting that this network of spins might one day bridge the gap between mind and matter. If everything is geometric information, could consciousness itself be a complex pattern within this same lattice? Let that question float softly, unanswered. What matters now is the certainty. The universe is granular, finite at its smallest scale, and immune to annihilation. The singularity dissolves in the face of structure. Now that we have uncovered the architecture of the floor beneath our feet, the beams and invisible bricks that construct our cosmic dwelling, we must look at what it contains. If this universe is enclosed, resilient, and built upon a protective lattice, what rare relics might it carry from before its expansion? What fossils from earlier cosmic cycles might still drift through the sky? Next, we will open the chest of cosmic curiosities and search for birthmarks. The subtle scars that suggest we are not the first chapter of existence. Now imagine yourself as an archaeologist, but instead of digging through soil in search of bones or fragments of ancient pottery, you are excavating the sky itself. If our story did not begin with a random explosion, but with a transition, a rebound from a previous cosmic era, then traces must remain. Transformations of that magnitude do not occur without leaving marks. The universe is an extraordinary keeper of memory. Nothing is truly erased. It is diluted, stretched, transformed, but rarely eliminated entirely. And right now, astronomers across the world point their instruments into the darkness, not merely to observe what shines today, but to search for what existed before our time began. What they seek are the scars of infinity. The first clue lies in the oldest light we can detect. the cosmic microwave background radiation. Picture the early universe, just after its expansion, as a bell struck with immense force. The vibration of that strike still echoes throughout space, now cooled into faint microwave radiation that bathes the Earth from every direction. If the beginning had been a chaotic explosion, this radiation should resemble uniform static, random, structureless noise. But when scientists map this ancient glow with extreme precision, they find subtle patterns that challenge pure randomness. Among these mysteries are what appear to be concentric circles embedded within that background radiation, a phenomenon proposed by mathematical physicists like Roger Penrose. Imagine a calm lake at night. If rain begins to fall, each drop creates expanding circles. If the storm is intense, the circles overlap, leaving intricate patterns across the surface. According to cyclic cosmology, in a universe that existed before ours, colossal collisions between supermassive black holes would have released gravitational waves of extraordinary intensity. When that universe contracted and transitioned into ours, those waves would not have vanished. They would have left faint imprints, like fossilized ripples, in the newborn fabric of space-time. What we observe today in the background radiation may be the wrinkles left behind by events that occurred before time, as we define it, even existed. It is as though we are seeing the echo of a storm that fell in another age of reality, and that realization is both humbling and magnificent. When you see static on an old television screen, part of that hiss is this very radiation, the oldest light in existence. Within that whisper may be encoded the memory of galaxies that lived and died before our sun was ever formed. The universe carries its tattoos. It remembers. But the clues do not end there. There exist objects in our universe that do not comfortably fit the traditional timeline. These are the so-called primordial black holes. According to conventional astrophysics, black holes form from the collapse of massive stars. Yet some candidates appear too small or too ancient to have formed in that way. They seem to have existed when the universe was only fractions of a second old. Where did they come from? The quantum rebound model offers a daring answer. They may be relics that survived the transition from a previous cosmic cycle. Imagine a massive compression event, the universe contracting toward its densest possible state. Most structures would be shredded into energy, erased in the compression. But perhaps some regions were so extraordinarily dense that they endured intact, surviving the passage through the bounce. These primordial black holes would be the hardened seeds that were not crushed. They would have crossed the threshold and emerged already ancient, already formed, carrying with them the physical memory of a prior universe. They would be the ultimate time travelers, silent witnesses to realities we can barely conceive. Some physicists even suggest that these relics could account for part of what we call dark matter, the invisible mass that holds galaxies together. The gravitational glue binding the Milky Way may partly consist of remnants from a universe long gone. We might be orbiting around the fossils of an earlier cosmos. There is yet another anomaly, one with an ominous nickname, the axis of evil. Despite the dramatic label, it refers simply to an unexpected alignment in the temperature fluctuations of the cosmic microwave background. If the universe began as a uniform explosion, it should look statistically similar in every direction. There should be no preferred orientation, no cosmic north or south. And yet, measurements suggest a subtle alignment, as if the universe possesses a large-scale axis. Why would that be? Explosions do not produce organized axes, but rotating black holes do. If our universe was born from the collapse of a spinning star in a parent universe, or if we reside within a rotating black hole, then inheriting angular momentum would be natural. The entire cosmos could be gently rotating, following the spin of its progenitor. What appears to be an anomaly may be inheritance. The so-called axis of evil could instead be the axis of origin, the rotational memory of the star that gave rise to everything we know. This transforms our cosmic environment from a featureless explosion into a structured entity, one with orientation, architecture, and legacy. These clues, concentric circles in ancient light, primordial black holes, large-scale alignments, form pieces of a puzzle still being assembled. They suggest that the universe is not perfectly smooth or sterile. It bears scars. It carries asymmetries. It contains relics interwoven with the new, and this imperfection is what makes it alive. A flawless universe would be sterile. A universe with birthmarks and memory is dynamic, historical, evolving. As you consider these possibilities, notice how mystery changes its tone. It no longer feels like terror. It feels like depth. We are not staring into an unknowable void. We are uncovering forgotten chapters. The universe is remembering itself through us. And there is something profoundly gentle about that idea. Just as dreams leave faint impressions when you wake, fragments of imagery, sensations that dissolve with morning light, the cosmos awakens from each cycle carrying traces of the previous one. We are the interpreters of those traces. Your own body is built from atoms forged in stellar furnaces that lived and died countless generations ago. The complexity that allows you to think and feel has been refined across cycles of cosmic contraction and expansion. You are not a random spark. You are the continuation of an ancient process. But if the universe carries scars from its past, it also carries invisible threads connecting distant regions in the present, threads that challenge our intuitive sense of separation. Distance itself may not be what it appears to be. Next, we will explore how everything, from particles separated by billions of light years to the atoms in your own hands, may remain deeply entangled, united by connections that transcend space. Now that we have walked across the scars of the past and felt the woven texture beneath reality, we must challenge one of the deepest intuitions you carry every day, the sense of distance. When you look out at a distant star or think about someone living on another continent, your mind instinctively measures separation. There is here and there is there. There is empty space in between. But what if that emptiness is not what it seems? Modern physics, the same physics that questions a singular beginning, also questions the reality of separation itself. Let us step gently into the realm of quantum entanglement. Albert Einstein once referred to it as spooky action at a distance. He found it unsettling. Yet today, we know it is real. Imagine two particles born together from a single energetic event, two photons emerging from the same flash of light. Because they share an origin, quantum mechanics tells us they are not fully independent objects. They form one unified system. You may take one of these particles and leave it here on Earth. The other, you send across the galaxy, millions of light years away. According to quantum experiments performed countless times in laboratories, if you measure the state of the particle here, the distant one responds instantly. No delay, no signal traveling through space, no gradual communication. It behaves as if the distance between them does not exist. This defies our classical understanding. How can something so far away know what happened here? The emerging answer is subtle and beautiful. Perhaps they were never truly separate. The separation we perceive may be a feature of our large-scale perspective, not of fundamental reality. Beneath the surface, in the same woven lattice of space-time we explored, the particles remain connected by the same thread. Distance, then, may be a kind of illusion. Now expand this idea. If the entire universe once existed in a compressed state, whether in a singularity, a bounce, or inside a collapsing star, then every atom, every particle that exists today was once intimately unified. Everything was once touching everything else. And quantum theory suggests that once systems become entangled, their correlations never fully disappear. They may become diluted in complexity, but the underlying unity remains encoded in the structure of reality. This means that, at a fundamental level, you are entangled with distant galaxies. The carbon in your body and the light from ancient quasars share a common ancestry. The air you breathe and the atoms inside distant nebulae were once neighbors in a compressed cosmic state. The universe is not a collection of isolated objects drifting apart. It is a single fabric folded over itself countless times. To deepen this picture, some physicists have proposed a daring idea summarized in a simple equation: ER, EPR. This proposal suggests that quantum entanglement, EPR, and Einstein-Rosen bridges, commonly known as wormholes, ER, may be two descriptions of the same underlying phenomenon. In other words, when two particles are entangled, they may be connected by an unimaginably tiny bridge in space-time, a microscopic wormhole, not a tunnel large enough for spaceships, but a subtle geometric connection woven into the quantum fabric. If this idea is correct, then the entire universe is stitched together by trillions upon trillions of microscopic wormholes, invisible threads binding distant regions into a unified whole. The solidity of reality would emerge from this network of connections. Gravity, entanglement, geometry, they would all be facets of the same structure. You are not merely located in the universe. You are a node within its web. This perspective softens the feeling of isolation. Even in solitude, you are physically connected to the totality. The particles composing your body are not sealed off. They are gently correlated with distant regions of the cosmos, participating in a silent dialogue across space. Nothing is truly separate, and this unity extends beyond matter to information itself. In a holographic universe, information about every event may be distributed across the cosmic boundary. Just as a shattered hologram still contains the entire image in each fragment, albeit at lower resolution, the universe may carry its whole history within every region. The air in your room carries quantum correlations stretching back to stellar furnaces. The light touching your closed eyelids tonight began its journey long before human civilization existed. Memory is embedded in structure. This realization invites calm. What we call chaos may simply be complexity beyond our immediate comprehension, an orchestra too vast for the ear to isolate individual instruments. Yet the symphony remains coherent. The future, too, is woven from these connections. It is not an empty void waiting to be filled. It is being constructed now, loop by loop, correlation by correlation, choice by choice. Reality is a loom in perpetual motion, and you are not being dragged through time. You are participating in its weaving. As you rest, imagine the invisible filaments that connect your quiet room to spiral galaxies turning slowly in distant darkness. The walls around you are made of atoms. The atmosphere outside is made of atoms. Interstellar space is filled with quantum fields. There is no abrupt boundary. It is one continuous ocean of existence, varying only in density. You are safe inside that ocean. You belong to it. And as we begin to understand this profound unity, a natural question arises, one that touches something deeply human. If the universe is so interconnected, so delicately structured, what role does consciousness play within it? Are we mere byproducts of cosmic processes, or is awareness itself woven into the architecture of reality? In the next movement of our reflection, we will explore the surprising possibility that the universe may require observers, that consciousness might be the mechanism through which the cosmos becomes fully real. We have arrived at a quiet and profound intersection, the place where hard physics meets the softness of human experience. Until now, we have spoken of immense structures, black holes giving birth to universes, granular networks forming the fabric of space, invisible threads stitching distant galaxies together. In the face of such immensity, it is natural to feel small. When we look at the night sky, filled with billions of galaxies drifting silently through darkness, a subtle voice often whispers, "What am I in comparison to all of this?" But the new quantum vision turns that whisper on its head. What if you are not insignificant? What if consciousness itself is a functional component of the cosmos? To approach this gently, consider a long-standing puzzle in physics known as fine-tuning. The fundamental constants of nature, the strength of gravity, the charge of the electron, the mass of elementary particles, appear calibrated with astonishing precision. If gravity were slightly stronger, stars would burn too quickly and collapse before life could form. If slightly weaker, matter would never clump into galaxies. If the electromagnetic force differed by a fraction, atoms would not hold together. The margin for complexity is extraordinarily narrow. Traditional explanations leave us with uncomfortable options, pure chance or intentional design. But there is a third possibility emerging from theories of black hole cosmology and cosmic reproduction. Imagine that universes give birth to new universes through black holes. Each offspring inherits the physical laws of its parent, but with slight variations, much like genetic mutations. In this picture, universes that produce many black holes have more descendants. Over vast cosmic generations, natural selection favors universes whose physical constants allow abundant star formation. And here is the quiet revelation. The same conditions required to produce massive stars, and therefore black holes, are also the conditions required to produce carbon chemistry and life, the elements that make your body possible. Carbon in your cells, oxygen in your lungs, iron in your blood, are forged inside stars. The chemistry necessary for black holes is also the chemistry necessary for you. Life may not be an accident layered onto the universe. It may be an inevitable byproduct of a cosmos optimized for reproduction. In this sense, we are siblings of black holes, born from the same stellar processes. The universe does not merely tolerate life, its structure encourages complexity. And then we step deeper into quantum mystery. At the heart of quantum mechanics lies an enigma known as the measurement problem. Subatomic particles do not behave like solid objects with definite positions. They exist as waves of probability, possibilities spread across space, until measured. Only when observed does the wave collapse into a specific outcome. An electron can be in many potential states simultaneously, but the moment of interaction, the act of observation, crystallizes one reality. For decades, physicists have debated what this means. Does consciousness play a role? Does the universe require observation to become concrete? Physicist John Wheeler proposed the idea of a participatory universe. In his view, reality is not fully defined until it is observed. The universe expands, forms stars, produces heavy elements, evolves life, and eventually generates minds capable of looking back at the cosmos. In that act of observation, the circuit closes. The universe becomes self-aware. You, in this quiet moment, are the cosmos perceiving itself. Without observers, the universe would be a vast equation unfolding silently. With awareness, it becomes experience. Light is not merely radiation, it becomes color. Vibration becomes sound. Molecular interactions become warmth against your skin. Consciousness may be the lens through which reality completes itself. This does not mean that the universe depends solely on human beings. Rather, it suggests that awareness, wherever it arises, is woven into the unfolding of existence. The cosmos evolves toward complexity, and complexity gives rise to perception. You are not outside the universe, analyzing it from a distance. You are one of its sensory organs. This realization softens the sense of isolation. You are not a random speck on a rock orbiting a minor star. You are the point where billions of years of stellar evolution have focused into awareness. And your biological rhythms reflect this cosmic lineage. Your circadian cycle mirrors the rotation of Earth. Earth's rotation reflects angular momentum inherited from the formation of the solar system. The atoms in your body were forged in stellar cores and scattered through supernova explosions. Each hydrogen atom in your cells is ancient, perhaps older than our galaxy. They have traveled across cosmic epochs to assemble temporarily into you. You are a fleeting arrangement of eternal components. When this arrangement changes, as all arrangements do, the atoms continue their journey. Nothing fundamental is lost. Matter transforms. Information persists. This perspective eases the fear of impermanence. The self as a pattern may dissolve, but the substance remains within the cosmic flow. And there is another quiet mystery. Why is the human mind capable of comprehending such abstract mathematics? Why can a brain evolved for survival on savannas grasp curved space-time and quantum fields? There is no obvious evolutionary advantage to understanding black holes. Yet the equations describing the universe align with mathematical structures we can conceive. It is as though the mind and the cosmos resonate. Perhaps intelligence is not accidental, but emergent when matter reaches sufficient complexity. Perhaps understanding is a natural phase of cosmic evolution, the universe exploring its own architecture through neural networks made of stardust. In that case, curiosity is not trivial. It is the universe asking questions about itself. And tonight, as you rest, that questioning pauses. The vast machinery of physics continues its silent work. Galaxies rotate. Quantum loops vibrate. Entangled particles remain correlated across unimaginable distances. But here, in your quiet room, the cosmos breathes through you. Your rest is not insignificant. It is part of the rhythm of a larger organism. You are not a stranger in existence. You are an expression of it. And with this understanding, that awareness may be the flowering of cosmic structure, we are ready to turn our gaze forward. If the universe is cyclical, interconnected, and capable of generating consciousness, what awaits in the distant future? Is there an ultimate end, or another transformation? We have traveled backward beyond beginnings. We have looked inward at the fabric of space. Now we must do the most daring thing of all: look forward. For decades, cosmology offered us a somber ending. The story went like this: the universe will expand forever. Galaxies will drift so far apart that the night sky will grow empty. Stars will exhaust their fuel. Black holes will slowly evaporate. In the far distant future, All that remains will be a thin mist of particles in a cold, dark expanse. This scenario is known as heat death. It is a future of maximum entropy, no structure, no energy gradients, no light. A universe fading into stillness. But if the universe is granular, if space itself has a minimum scale, if expansion is not an infinite runaway but part of a deeper cycle, then the ending may not be extinction. It may be transformation. Imagine the universe as a lung. It inhales expansion. It exhales contraction. Right now, we are living in the inhalation. Galaxies drift apart as space stretches. But if gravity regains dominance over dark energy, or if dark energy itself changes character over unimaginable timescales, the expansion could slow. Eventually, it could halt. And then, almost imperceptibly at first, the cosmos would begin to contract. Galaxies would slowly reverse their retreat. The night sky would brighten as distant structures draw closer. Temperatures would rise. Matter would gather. What once expanded outward would begin to fall inward. But because space is woven from quantum loops, because there is a minimum resolution, the contraction would not end in infinite collapse. It would approach a limit. The loops would compress to their maximum density, and just as before, the resistance would grow. Quantum repulsion would build like tension in a compressed spring, and then a rebound, a great bounce. A new expansion phase would begin, a new cosmic dawn. In this picture, our universe is not traveling toward oblivion. It is traveling toward renewal. Heat death becomes only one phase in an eternal rhythm. Spring follows winter. Expansion follows contraction. The cosmos is not a line with a terminal point. It is a pulse, and this perspective dissolves the fear of ultimate endings. But the future holds more than cosmic mechanics. It also holds the evolution of intelligence. If universes reproduce through black holes, if complexity is favored because it allows more stellar formation, then what role might advanced civilizations play? Some physicists have proposed something astonishing. If sufficiently advanced beings learn to manipulate gravity, to compress matter to extreme densities, they might create artificial black holes. And if black holes generate new universes, then intelligence could become an active participant in cosmic reproduction. Imagine that. A civilization reaching a level of understanding where it can seed new universes, each with slightly altered physical constants. In such a future, intelligence becomes the reproductive organ of the cosmos, not by intention of destiny, but as a natural extension of understanding. The universe evolves matter. Matter evolves life. Life evolves intelligence. Intelligence learns the structure of reality, and perhaps one day intelligence learns to initiate new cycles. In that scenario, we are not merely passengers drifting through time. We are early expressions of a process that may culminate in conscious cosmic creation. Even if humanity never reaches such heights, the possibility reframes our place in existence. The universe may not simply produce awareness for observation. It may produce awareness for continuation. And what of other universes? Theories like string theory suggest that our universe may be a three-dimensional membrane, a brain floating within a higher dimensional space. Other brains could exist parallel to ours, separated by dimensions we cannot perceive. Occasionally, these membranes might interact. Their gravitational influence might subtly leak across dimensions. One day we may detect signs of neighboring universes not through light, but through gravitational fingerprints imprinted on our own cosmos. Isolation may be temporary. The future of physics may reveal that we are part of a vast multiversal landscape, an archipelago of realities. But bring your attention back from those distant horizons to something more immediate. What does this future vision offer you tonight? It offers freedom from urgency. If existence is cyclical, if reality renews itself endlessly, then there is no final deadline pressing against your life. There is no cosmic stopwatch counting down toward absolute erasure. Transformation is not catastrophe. It is continuity. Even on a personal scale, the analogy holds. The end of a day is not annihilation. It is preparation for another dawn. Sleep is not disappearance. It is restoration. The universe models this pattern at every scale. Stars collapse and give birth to black holes. Black holes may give birth to universes. Universes contract and expand. And you, in your small human rhythm, wake and sleep, breathe in and breathe out. The macrocosm mirrors the microcosm. There is comfort in knowing that nothing is wasted. Energy transforms, information redistributes, structure dissolves and reforms. The stage remains, the scenery changes, and perhaps in the distant eons ahead, intelligence itself will evolve beyond biological limits. Minds may merge with technology. Consciousness may extend into quantum substrates. Communication might one day occur not through wires or waves, but through direct manipulation of entanglement. The boundary between matter and mind may soften. Empathy may become literal, a resonance within the cosmic web. It is possible that the future of awareness is deeper integration with the structure of space-time itself. But none of this demands urgency from you tonight. The timeline of the cosmos stretches across trillions of years. Your role right now is simple: to rest, to participate in the present moment, the only point where the wave of possibility collapses into reality. And as we prepare to complete this journey, gather everything we have explored: a universe without absolute beginning, a structure woven from quantum loops, a cosmos bearing scars of previous cycles, an interconnected fabric where distance is illusion, a reality where consciousness may complete the circuit, a future that bends toward renewal. Now we are ready to land softly. We have reached the quiet edge of our journey. Tonight, we traveled beyond beginnings. We stepped inside black holes. We touched the woven threads of space. We listened to echoes older than time and imagined futures where universes are born again. And now, all of that vastness gently folds back into this simple moment. You are here, breathing, resting, held by gravity, supported by the same quantum lattice that sustains galaxies. There is something deeply calming in realizing that there was no violent accident that hurled you into existence without context. Instead, there may have been continuity, a transition, a passage from one phase of reality into another. If the universe is cyclical, if it expands and contracts like a cosmic breath, then existence is not fragile in the way we once feared. It is resilient, structured, self-renewing, and you are part of that structure. Feel your body again, the gentle weight of your limbs, the steady rhythm of your heart, the slow rise and fall of your chest. Each breath mirrors the expansion and contraction of the cosmos. Each heartbeat echoes the pulse of a universe that refuses to collapse into nothingness. The darkness behind your closed eyes is not empty. It is full of geometry, of potential, of silent motion at scales too small to see. The same loops that prevent cosmic collapse are quietly holding the floor beneath you stable. You do not need to guard reality tonight. The equations are balanced. The constants are steady. The Earth continues to rotate because angular momentum is conserved. The stars continue to shine because nuclear fusion follows precise laws. The morning will arrive because the universe is consistent. Physics is reliability. Let that reliability relax your mind. If black holes are wombs, if singularities are doorways, if every ending is compression before renewal, then sleep itself becomes sacred. When you fall asleep, you are not disappearing. You are entering your own small bounce, releasing the structures of the day so that they may reorganize by morning. Memory consolidates, energy restores, consciousness softens and then reemerges. The cosmos does this on scales of billions of years. You do this each night. There is no rush. The universe is not counting down, it is unfolding. And perhaps the most beautiful realization of all is this: you are not separate from the vastness we described. You are not an observer standing outside of it. You are a local expression of it. The atoms in your body were forged in stellar furnaces. The space within your cells is the same woven space stretching between galaxies. The awareness listening to these words is the universe reflecting on itself. When you rest, the cosmos rests through you. When you dream, the cosmos explores through you. When you wake, the cosmos opens its eyes again. So allow your thoughts to slow now. Let them drift outward like galaxies receding into the dark. There is nothing left to analyze, nothing left to solve. The questions can dissolve into softness. You are safe inside the structure of reality, protected by horizons you cannot cross, carried forward by time's gentle current, connected, at levels beyond perception, to everything that exists. Let your jaw relax. Let your shoulders sink. Let your breath become effortless. Imagine yourself floating inside that vast cosmic womb we described, not as something trapped, but as something cradled. The boundary is not a prison. It is protection. Beyond it, whatever exists does not disturb you. Here, inside, the temperature is right. The forces are balanced. The geometry holds. The night deepens. Thoughts thin out. Awareness softens at the edges. You do not need to hold the universe together. It holds itself together, and it holds you. And as this reflection comes to its natural close, if this journey through space, time, and quiet understanding brought a sense of calm, you're invited to remain connected with Cosmos for rest. Subscribing allows you to continue exploring these vast ideas in a steady, unhurried way. You may also share this space with someone who needs a little more wonder and peace at the end of their day. For now, though, there is nothing more to do. The universe is in motion. The stars are steady. The laws are constant. And you are exactly where you belong. Sleep gently, sleep deeply. Everything is in its place.